So here you'll see the cleaning process, how I'm doing this. Yeah. Sorry for that movement of camera. I touch with my arm the tripod. I'm still working on this system, how to fix the camera around me. Maybe you can help me with this. Maybe you can give me some information how to fix better the camera. You see, because if I'm touching the tripod, it's moving, it's shaking. Yeah, I will try to avoid to touch this. This was like an example to you to see how I'm fixing here the camera. Yeah. So now we are continuing with cleaning the printed circuit board. Here is it's a Sony amplifier TAF7A. It's a very nice amplifier with FET power transistor. Yeah, like you saw a couple of minutes ago. And I take out the transistors. The sound is outstanding. This is a real good amplifier. And of course have more than 35 years old. It was built on that era when the things they were well done. Yeah. Okay, so let's stick to our situation here. Like I said, here is the Power Amplifier circuit board. Yeah, this is the amplifier. It's upside down. That means now on my hands is the left amplifier. Yeah. Now here is the undusting process. Yeah, I want to remove the dust first. I'm using different brushes to do this because, to be honest, I hate this dust, and in my opinion a good restoration means also removing this dust which it was collected here in the last years in service of this unit. Yeah, and it's similar for all devices from this era, and of course depends where the gear was stored. In home all the time, in stores, I saw some amplifiers and some devices, they were stored in basement. So try to imagine what is there, or on the roofs. Yeah. So here it looks, how it looks after the dust was removed. Yeah. Now I will use some contact cleaner. I'm using this professional CRC. Yeah, it's focus. Let's focus the camera. Yeah, it's CRC 226, electro maintenance and protection. Yeah, it's industrial, and he's doing a good job. So this one is helping me. So you see how I'm doing. Yeah, I'm putting a drop here on the brush. I'm using this circular brush. It's for I think this one is for painting. It's a paint brush. Yeah, you see. So now this contact cleaner, he is inside here. Yeah, between the hairs of the brush. Yeah, and easy when I'm playing with the brush here and I'm brushing the PCB. This chemical he is distributed evenly here. Yeah. And he is leaving also, he is removing the dust, residues, depends what is in amplifier or circuit. Yeah? I remember a couple of years ago, I bought an amplifier because I was curious since I was young how an amplifier it works. Yeah? So I have a very strong connection with amplifiers. So I remember a couple of years ago, I think more than 10 years for sure, my first amplifier was a Sony TAF 4A. Yeah, so it's same generation like this one, which is here on the bench. It's my first video on YouTube channel. And of course, if you like my videos, if you like what you are seeing here, if you have questions, you can subscribe on my channel. And of course, you can leave also comments or, I don't know, ideas, suggestions. If you want to see something else, if you want to see what tools I'm using here on the bench, from where I'm ordering the parts, what kind of tools I'm using for each steps, you can leave here a comment or. And of course, subscribe if you want to see the last release or if you want to see the previous movies. If you like, you can share also with your friends or others. And of course, the thumb up, it will be perfect for the channel, yeah, to grow up and to see the feedback which is coming from you according with what I'm posting on the channel, yeah. So, like I said, that Sony TAF 4A, I remember when I bought it, it had a problem inside because somebody he dropped some coke inside, yeah. So it was a total mess there. That coke he managed to create a short circuit there, and somebody after this problem he was trying to fix, but he was not fixed properly, yeah. He was replacing some parts with wrong parts. I mean, what means wrong parts? He used some transistors, but they were not suitable for that kind of application, because like here, you see, here is an IC. This IC, he is responsible to adjust and to maintain the DC offset of this amplifier, yeah? So the balance on the output, which is going to the power transistors and of course to the speaker, when you don't have signal on inlet on the power amplifier board, the DC offset he is taking care about the stability of the speaker. What I want to mean, the speaker should stay on that point, yeah. When a speaker is disconnected from the amplifier, he is sitting on the standstill position, yeah. When that speaker he is connected to the amplifier, that speaker should stay same, yeah, if the DC offset is adjusted properly. But usually, because of the years and because of the valorization of the parts, the DC offset he is jumping more or less closer to the 0 point. On some amplifiers, like example this one, he is making the DC offset automatically, but also you can adjust with the trim pot, which I remove from here, yeah. So after you remove the trim pot, the IC he is doing the rest of the job, yeah. On other amplifiers, you can have trim pot, or you don't. Or also it's can be missing, yeah. And to do that, you have to adjust and to match proper the differential amplifier stage on the amplifier board, yeah. The differential stage is the first part which is taking the signal from preamplifier, yeah. Preamplifier signal from preamplifier is coming on the differential stage first, and the differential stage, if you have a problem on the differential stage, you have to match both transistors, which are two transistors, they can be on the same package or different, like here, yeah. And you have to match properly the HVE, the amplification factor, yeah. So on that Sony, which I said, the problem was with that transistors because the previous technician was not matching proper the transistor, and on the outlet was a high DC offset. And of course, with that DC offset, I was not able to play proper the music, yeah, because the speaker, they were all the time. Depends how the voltage is, positive or negative. If it's positive, the speaker is in one position. If it's negative, the speaker is on the other position. And the music he will start to play from that position. So now, like example, if the brush it's 0 DC, the speaker is on position. If it's positive, the membrane of the speaker, it will stay here on this position. If it's negative, it's below that center, yeah. Is below that center. So when you start to adjust the DC offset, you'll push the speaker cone on the 0, yeah? This is how it's dealing with the DC offset. And of course, this is the first setting, which we have on this printed circuit board, and the second setting is the idle current, idle trim pot, which is adjusting the current, the current from power transistors. But about the idling current, we will discuss when we will start to make the adjustments, if you want, on the later on records. Yeah. So I think I talk already too much about this board and about the cleaning and about the parts which are here. About the replacements, you saw I removed 2 trim pots which are oxidated already. You can see this is the reason why I am replacing this. It's plenty oxide, and in case, you know, on the trim pot it's a wiper inside which is turning around this omega shape, yeah, the resistor pad, yeah. If you'll have too much oxidation, the wiper he can lose the contact from his pointer, which is connected to the omega resistive pad. If it's losing the contact, in that moment you can have a high current on the power transistors, and the amplifier can be burnt, yeah. So what I'm doing, I'm replacing these old trim pots with new trim pots from Burns, yeah, like you see here. Let's see if it's visible. I'm trying to check. Yeah, it's visible. So these original trim pots have less than 1 turn rotation, yeah. It's below 1 turn for sure. And this new have 12 turns. Yeah, this is a multi-turn trim pot. So the adjustment, it's perfect. On the other side, the old trim pot, it's open, yeah. So it's not completely sealed, yeah. Is this cover here, but if I will put a screwdriver, I can remove this one, yeah. On the Burns, these multi-turn pots, you see here it's like a how to call this one? It's like a epoxy, yeah, and it's sealed, yeah. So there's no any chance of oxidation or going humidity inside to oxidate. So I think this is the problem. Okay, so now it's perfect here. Yeah? So here here are the parts which I'm replacing. So are 2 trim pots. I'm using same manufacturer for this, and 2 capacitors on this board, 10 microfarads on where I put. Yeah, so these are the original 10 microfarads. It's visible, 16 volts, and I'm using from Nichicon. I'm using the what series is bipolar transistor, is bipolar capacitor, and this one is 10 microfarads. 10 microfarads on 50 volts. Let's see if it's focused, this one. Yeah, BP, 10 microfarads, 50 volts. This is what I'm using for this one. Yeah. So step by step, I'm continuing to this board. And after that, like you see here, like you saw on the beginning, I removed the drivers, power transistor drivers, which are designated to deliver the power to the power transistors, yeah. And here I want to replace these pads. Yeah. Like you see, the grease is dried. So in the last years, because of the temperature, high temperature of these transistors, the grease, it's not anymore like a grease, yeah. Now it's like a powder, yeah. And what I will do, I will replace these mica pads. I will replace with silicone pads, which are available, and for sure they will do the perfect job for this application, yeah. Perfect. So I will continue the job here with you, and we'll discuss about. Okay, so now it's the time to clean the board on the tracing, yeah, side. Let's see if it's visible. It's visible. Here is some dust below. which I have to clean to look nice, to be ready for a new life. Yeah, how I'm doing with this? Yeah, you see, it's visible, the flux. See here, it's flux. To be honest, I don't like this flux to be visible. There's no any problem if you can leave, if you leave here, it's not conductive, he will not conduct the electricity, so it's no any problem. But I prefer to be clean. Yeah. So how I'm dealing with this? I'm using the isopropylic alcohol. Yeah, I'm using on this spray, which is it's very handy for me to have here, like in this manner. Yeah. So how I'm doing? I'm spraying here some IPA. Yeah. I'm taking a brush. I'm putting also on the hair of the brush. And now I'm starting to scrub. But before of this, I want to put a rag here. I will put a rag because all this IPA, he will jump inside the amplifier. Yeah. So now I'm trying to touch all points. Yeah. Where is this flux? I am helping again with some IPA, which now you see after I will brush that part. When I am putting IPA, it will clean the flux, which is already melted. Yeah. And because of the gravity, he will fall down on the way. Yeah. Okay. Okay, so now here, so you have to pay attention for the small pads, because if you are pushing harder, you can lift up. And you know, on this kind of vintage devices, usually some of them they work on high temperatures because of the valorization of parts. The currents, they were changed inside here. And also depends on the speakers which the owners before they used. If they were on 4 ohms or 2 ohms, you know, the temperature is increasing and the traces. You see, this one, it looks okay. There's no any brown marks nowhere. But on other devices, you can see brown spots. So you have to pay attention on that points when you are desoldering or soldering. Try to avoid to keep the soldering gun or desoldering gun for too long period, because you have high chances to lift up the traces. Yeah. Okay, so now I'm cleaning this. You see. Okay, I'm doing like that until the IPA and this flux, they will be dry. Yeah. And after they will be dry, I will use same CRC 226 for a shiny look. Yeah. Also now for sure it looks better than before. Yeah. You see, it's no any flux here. Perfect. And I will push some air here to dry faster than the IPA. So here how it looks. I will take a rag, clean my hand. Usually I'm using gloves, and for sure you have to use the safety glasses for this when you are doing this. And of course, if you don't have experience with this kind of jobs, don't do it at home. They are risky. Yeah. So pay attention. For sure you have to pay attention for all steps which you are doing. Yeah. Okay. So now the board is cleaned. The flux is removed. Like I said, I will take again the brush and the contact cleaner, this one. I will push Okay, on the brush. I'm cleaning the brush because you saw me a couple of minutes ago. I used the brush to remove the dust, yeah. So the dust now it's here inside, but I'm cleaning how much I can. You can see on the rack, yeah. You see, it's dirt, yeah. But now the brush is clean. So again, some contact cleaner, and now we'll change the look of the board, yeah. And now it will be shiny and nice, yeah. Again, because it was not enough. So you see, to make proper one board like this one, it will take a long time. It will take some minutes to fix, to clean, to do a proper job, yeah. Yeah, okay. So like I said, if you like what I'm doing here, subscribe, thumb up, share with others, leave comments. If you want to see my tools, what tools I'm using, some review about the tools, you can write me on the comments and I will try all my best to answer to you. And about, I don't know how to say about this, but I will say somehow. The English is not my native language. I'm living in Europe, but this electronic is my passion. It started when I had 5 years old, and since that time I was continuing to learn, self-learning, let's say. I bought the parts, the tools I remember when I was on the kindergarten. I was very happy when my parents, they left the home to go to work. I was very happy because in that moment I was able to take the the power amplifier which they have on that time, and I was opening to see what is inside. So I was very curious about this, and you see, since that time I'm still doing this. Okay, so now it's time to see how it looks on the bottom. You see, it's shiny and glossy, yeah. Good here. So now I will start to put the parts inside, yeah. So I will start first with capacitor. I have to bend a little bit the legs, yeah, because how they are calling, PCM, if I could remember, PCM, yeah, the distance between the leads on this board, it's smaller, it's bigger than the leads of these capacitors, and to make perfect fixing, I have to increase the distance between the leads, yeah. So you see now it's coming proper here. Now I will bend the legs on this side. I will do same for the other. So like I said, these capacitors are bipolar, yeah. So it doesn't matter how you will fix. If you are looking here, I don't know if you see on this distance, but I think it's visible. You see here is the mark of the capacitor, and here is the minus sign, yeah. But these capacitors which I'm using now are bipolar, and doesn't matter how you'll fix on the board, because they don't have a plus or minus, yeah. So now I'm checking the parts to be aligned with the others, yeah. So they are okay. I'm turning the board back, and now I will solder them, yeah. So I'm cleaning the tip of the soldering tool on the wet sponge, yeah, to be clean. So here it's how it looks, my soldering tip, it's cleaned. And now I'm looking for the solder wire, yeah. I'm using what kind of, this is 1 millimeter, yeah, because also the pads of the old vintage gears, the pads also are bigger than what is now on these days, yeah. So I can use bigger wire, yeah, for this kind of soldering. This wire, it's with flux inside. So if you are cutting and if you are magnifying the cross section of this wire, inside it's a flux, which is helping me to make a better soldering. Yeah. So how I'm doing? I will clean again the tip because I was discussing and it happens some oxidation on the tip. So how I'm doing? I'm putting the tip on the pad, and I'm pushing the solder between the tip and the pad. Yeah. So now I will leave this pad to cool down. Yeah, because behind of this one is the capacitor, you know, and it's better to not overheat the capacitor. Yeah, because you can destroy. So avoid how much you can to keep a longer contact with capacitor. Yeah, I'm doing to the second one. I'm doing to the second one capacitor, and same. I'm putting the soldering tip on the pad, and after that I'm pushing the solder between the pad and the tip of the soldering tool. Yeah. So remains the last one. Same. Yeah. So it's a perfect soldering. Yeah. I don't know if you can see. It's shiny. It's well done. So now I have to cut the legs, the wires, terminals. I think this is the proper word. I have to trim the terminals of the capacitors. Yeah. So how I'm doing? I'm keeping with my hand, or I'm trying to help myself with a tool, and with the plier I'm cutting. Yeah. I'm using this plier from Knipex 7803-125. Yeah, you see it's for copper it's 1.6 diameter, and for metal it's 1. Yeah, and like you know, these leads for the parts are from copper. Yeah, so I have enough room to cut this. It's a spring behind, so you don't need to move or to open by your fingers. Yeah, it's opening automatically. So it's very good tool. Here you see it's flat on this side, and here it's angle. So he is cutting exactly from the surface. Yeah? Let's see if it's focused. You see, directly. Okay, good. Enough with this. So our capacitors, they are now soldered in position. Now I will start with the process of cleaning this sorry for this. I will start with the process of cleaning this transistor. So we'll continuing with this. I will put now on pause. Okay, so now I will take out the transistors. I will need a screwdriver. Okay, so how I'm doing? So I will unscrew the screws here. Okay, so one by one until all of them they are out. Yeah. Easy. I will put the transistors back. So I'm trying all the time to put the parts, I mean the transistors back like they were before. Okay, so here are the mica pads. I will use now a cutter blade to remove this one which are sticked here. Okay, so like I said, this grease is not anymore grease. Now became powder because of the temperature, and because of the temperature they became dry. Yeah? And now I will use a rag. Again, I will put some HIFI on the pad. and I'm cleaning the old heat transfer paste, yeah. Circular movements, you see how I'm doing. So this one, it looks okay now. It's not any more flux. It's no, sorry, not flux. Heat transfer paste. Yeah. So try to clean how much you can, yeah. After that, I'm using a brush because I want to remove the dust which is inside. So I'll use a brush for this. With long hair. Okay. So you see, this one it's ready, yeah. No more dust inside, so it's ready. It's ready to do his job later on. So now with same rag, I'm putting more HIPA. I will clean all the transistors, yeah. Okay, one by one until they will be cleaned. Good. So this one is ready. I will put back second one. You see, there's no any oxidation on the terminals, so this is good. Usually, when it's oxidation on terminals, you have to clean. You can use some eraser to do this, or you can use a sharp blade or a deoxide to remove that oxide. Why? Because if you leave like that, when you'll try to solder back, I don't think so. So you will be able to fix back the transistor on the hole of the screw. Yeah? You will have here it's some room when you'll fix back, and if you will not fix like it was, it's possible the oxidation to reach the soldering pad, and if you reach this, the soldering, it will not be perfect. It will be like a dry joint there. So it's better to use, like I said, a sharp blade to clean a little bit that oxidation, to scratch that oxidation to reach the shiny part of the terminals. Like you see this one, all these, they looks perfect. They are shiny. Okay, now I will take another rag because the other one was already full with paste, and I will do the last touch, let's say. Okay, this one and this one. Now I will clean a little bit this, let's call it support, because it's some powder here. Okay, I will put back. I will take the radiator, aluminum radiator. I will put on position, and now I will look for pads here. I have on the side. Oh. Okay, I will put the pads on position, silicone pads. Yeah, like that. It's visible. It's visible. Perfect. Yeah, I will try to align the whole of the pads with the hole on radiator, yeah, from radiator. Okay, and now I will take the transistors, and more or less I will try to put on the pads, but we will align now when we will put the screws. So first screw, okay, screwdriver. Okay, and now pay attention to not lose the plastic washer. Yeah? This plastic washer, he is making the insulation between transistor metal tub